Welcome to lesson 32 of our interactive notes. We're looking at comparing fractions with models, pages 11 and 12. All right, so here our content objective for 4th grade, N, numbers, operations, fractions, A2. I can recognize that comparisons of fractions are valid only when the two fractions refer to the same whole. I can compare fractions using symbols and justify the comparisons by using models. Our language objective, I can use vocabulary related to fractions to communicate how to compare fractions. And social objective, I can work with others to create models to prove the comparison of fractions. So we're going to start off here. We have two Hershey candy bars. Definitely not the same size. We have a king size. We have a little even smaller than a fun size. Your brother gets 1/2 of the candy bar on the left, and you get 1/2 of the candy bar on the right. Since both of you received exactly 1/2 of a candy bar, did you get an equal amount? Do you think this is fair? Explain your answer. So even though you both received half, he had half of this and you had half of this. Is that the same? No. Definitely not. No. My brother and I did not get an equal amount and why didn't you? Well, because his 1/2 is bigger than your 1/2. The whole is not the same size, so the fraction is not the same size. Half of a larger object is still going to be bigger than half of a smaller object. So the explain part, no, my brother and I did not get an equal amount because his 1/2 is bigger. Is bigger than my 1/2. It is not fair because, let's see if we can fit this in. It is, I know it's little, not the same. So remember, when we're looking at fractions, they have to be the same size whole. Otherwise, we're not comparing the same type of things. So here's some examples. We have half a rectangle. We have half a circle. They're almost the same height, but they're not the same shape. Well, since they're not the same shape, we can't compare them, kind of like these, because we're not going to get exactly the same amount. Can these two fractions be compared? No. They are not the same type of shape. Because they're different shapes, even though they're about the same length, their amounts aren't guaranteed to be equal. We have to be comparing the same whole. So here we have two circles. So we have the same shape, but can we compare them? No. They're not the same size. They not the same size. So they have to be the same size. They have to be the same shape, which we have a word for. It's called congruent. They have to be congruent. They have to have the same size and same shape. These two are both circles. They're both the same size. Can we compare these? Yes. They are the same size and shape. They're both circles and they're both the same size. Now our pieces inside are different, but we're looking at the whole. When the whole is the same size and shape, then we can compare its pieces. So like here, we have two rectangles, and the whole is the same size, even though our pieces are different. Now these should already have been shaded. Actually, no, they're not. Okay, I'm sorry. You're going to need your highlighter again. Sorry, I didn't say that earlier. So you'll want to get your highlighter out. And we're going to be using models to help us to be able to compare fractions. So when we're comparing, that's greater than, less than, or equal to. So here, we're looking at 1/4. So this one's cut into 1, 2, 3, 4 pieces. And I'm going to shade in one of those 4. And here is 4/5. So there's 1, 2, 3, 4, 5 pieces, and I need to shade in 4 of them because the numerator tells me what I want to get shaded in, what I'm going to compare. Now that we have it shaded in, is this 1/2? Is this area here less than this? Greater than the 4/5? Or are they equal? Well, this takes up less area than this is. This is a much greater area. So 1/4 is less than 4/5. Okay. Now we're going to look on this number line. So we're looking at 2, 6. I know the fractions are very, very small, but you can see which one is cut into 6 and which one is cut into 8s by counting the pieces in between the lines. So this is 1, 2, 3, 4, 5, 6, 7, 8. This one's the 8th, so this one we'd look at 3/8. So just like with our daily fraction, if we start at the 0, this is 1 piece, 2 piece, 3 pieces out of 8. Those are our 3/8. And this one is cut into 1, 2, 3, 4, 5, 6 pieces. So we go 1, 2. Now these two are much closer together than these two were. So it may be a little harder to tell, but if you draw a line straight down here and straight up here, this right here looks like it takes up a little more area than this one. Just barely. But it looks like 2, 6 is less than 3/8. They're very, very close. They're almost equal. But there's still just a little bit more area covered with 3/8 than 2, 6. Okay, for this one, we need to shade in 8/9. Well, this one looks like it has 9ths without having to count it because this one only has 3. So I'm going to shade in 8 of them. There's 5, 6, 7, 8. Should be one left over not shaded in. The whole thing is almost full. It's almost 9/9. Should be the whole thing. And then this is 1/3. Well, let's see. Is there more area shaded in here than here? So is this less than this, greater than this, or are they an equal amount shaded in? Well, there's much more of the circle shaded in for 8/9 than 1/3. So 8/9 is greater than 1/3. So we can use rectangles that are an equal whole cut into pieces. We can use equal size circles cut into pieces. We could use equal size number lines cut into sections. We can use fraction bars cut into sections. So here we're looking at 5/10. You can kind of see where the 10, where it says tenths, and 6/12. It's harder to see the 12ths, but 1, 2, 3, 4, 5, 6. I know the line didn't copy well, but you should end up with exactly the same amount shaded in, because 5/10 is exactly half of 10 and 6/12 is exactly half of 12. So we end up with 2 halves right there. So these two are equal. So we're going to just do some more practice over here, looking at equal size and shape holes cut into pieces. So here we have 11/12 and 5/6. Is 11/12 less than 5/6, greater than 5/6, or are they equal? Well, they're both missing one piece, but this one piece is much smaller than this one. So this area that's shaded in is greater than this area shaded in. Okay, this may be hard to see because you can't really see the lines here. I mean, you can barely see them. So you may want to retrace those. But here we have 3/6 compared to 4/5. Is 3/6 less than 4/5, greater than, or equal to? Well, this area is much smaller than this area, so 3/6 is less than 4/5. Okay, here it's hard to see the numbers, but this is cut into 1, 2, 3, 4, 5 pieces. So this shows 3/5, and this shows 5/8. They're very, very close. But if you put this straight up, you can see that 3/5 is just a little bit shorter than 5/8. So 3/5 is less than 5/8. Here we have on top 3/9 and then 4/12. I know it's hard to see the numbers, but you can see that there's many more pieces down here, so that has to be the 12ths. But if you look, both of those areas have exactly the same amount shaded in, so these are equal. These are equivalent fractions because the same amount is shaded in. Here we have 5/7 and 5/11. Well, 5/7 is a much greater area shaded in than 5/11, so 5/7 is greater than 5/11 when we're talking about the same whole, same shape, same size. Here, this top one is our 4/8 and the bottom one is 5/10. It's hard to see the numbers, but you can tell that both of them are exactly the same. 4/8 is 1/2. 5/10 is 1/2. So these are equal. They're both exactly half of their lines. So they're equivalent fractions. Here we have 1, 2, 3, 4, 6. And we have 6/9. And exactly the same amount is shaded in on both. So these are equal. These are equivalent fractions. The pieces, the size of the pieces are different, but the same amount is shaded in. Here we have 1, 2, 3, 4, 5, 6 out of 10. It's hard to see the other 4. And this one, it looks like it's actually 2/4, but 2/4 is 1/2. They're equivalent. So which one is greater? The 6/10 or the 2/4, 1/2? Well, this is a slightly more of the area of the rectangle is filled in. So 6/10 is greater than 1/2 or 2/4. Here we have 1, 2, 3/7, and we have 3/4. Even though they both have 3 pieces, these pieces are much bigger. So these 3 make up a larger area than these 3. So 3/7 is less than 3/4. Okay, so it's harder to see these pieces, but this one's the 1/4. And this is the 1/6. So these are those unit fractions. These are those unit fractions, and they both have just one piece. But because the 1/4 pieces are bigger, it's only cut into 4, this one's cut into 6, this one piece is larger than this one piece. So this unit fraction, 1/4, is greater than the unit fraction, 1/6. So 2/5, even though you can't see that they say fifths, these 2 fraction bars are 2/5, and these 3 are 3/8. They're very close to each other, but you can see that this fraction bar goes out just a little further, so it's a larger area than this one. So 2/5 is greater than 3/8. Takes up a larger area. Here, this is the 1, 2, 3, 4ths. So here's 1/4, and this is 1, 2, 3, 4, 5, 6, 7, 8, the 2/8. Well, they go to exactly the same spot on the number line. So they take up the same area on the number line. They are equal. They're equivalent fractions. 1/4 and 2/8 are the same thing. All right, let's go ahead and do some more comparing fractions in part 2 of our 3-column note.